Okay, again, good morning, guys. This is Sir DB discussing to you the basic procedure on how to use an application software compatible with STAAD.Pro, known as the STAAD Foundation. Okay, so to begin with, I'd like you to present to you the interface of the STAAD Foundation. It's a simple interface having three or four workspaces. We have here the navigator at the left side. No? In the middle part, we have here the workspace wherein you can see the geometry page, the detailing page, the drawing page, okay, calculation sheets, and graph. Now, in case you need them. But what is important here is, of course, only the input parameters, so as you will be obtaining the output later. Basically, the dimensions of the footing are the ones that are very important, including the reinforcement. So for this particular presentation, I would like to focus my discussion on isolated footings or spread footings only. Okay. On the right part here, we have the data window or the data input pane, wherein you are ought to give some details on what this navigator wants you to set in terms of the parameters involved. Okay, and at the middle, at the bottom rather, you have here the output pane or the output space, wherein later on you will see some drawings, tables, and illustrations after uh, doing the design calculation. Uh, the output data will be available on this screen. So the first thing to do is, of course, is to open a file. Here we have the menu bar available for us to open or import a STAAD profile. Okay, so I normally uh, import the STAAD file first because if they don't have any opened file which you have previously made, you cannot open anything. Okay, so you need to import the STAAD profile from your folder. Okay, okay, so this is my folder on the model we made in STAAD. So I just select um, the 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 L8 lecture here because the L9 footings here are based on the STAAD 2004, which most of you cannot download, no? So punta tayo dito sa L8. Okay, after opening it, you can see that the STAAD uh, file you have created, no, is now imported, no, to this STAAD foundation, wherein the base reactions are the ones that are taken to start with your analysis and design of your foundation. Okay, so we just click import here, and automatically the geometry will be given into your or be placed in your geometry screen here. Okay, so if you can see the the footings are numbered the same way it's numbered on your STAAD profile. Okay, okay. So the next thing to do after you have uploaded it is to go to your navigator page, wherein the general specifications of your foundation are actually placed into several categories in terms of the project info, the plan itself, the loads and the load factors, and the setup of your footing design job. Okay, so the first three here are actually important, but they are not so important since you can optionally omit them because they are just here to add up to the uh, information you need. No, for the project information, of course, these are very important to give you some description on the design job you are doing. For the foundation plan, the column positioning, the dimensions of the column, etc., may be added, no, to enhance your illustrations later. Okay, so your output later. But again, they are not so important because you can do away without changing them. So we might as well study them later. So for the loads and factors, we have here some creation of the new load cases in case you are not satisfied with the load cases you have defined in your STAAD.pro. Then you can add up to creating new load cases. You can add column reaction loads based on additional maybe surcharge, additional loads coming from other sources, etc. Okay. You can also add the load uh, in terms of point loads which were not taken care of during your modeling in your STAAD.pro as point load, line load, quadrilateral load, circular load, etc. And also you can add member loads. No? So in short, class, these loads and load factors are those those additional uh, unexpected loadings that you have not considered in your STAAD profile. Because some loads are not considered in your superstructure yet, and then when it comes to the design of your substructure, you need them. So this will take care of such uh, shortcoming in your modeling during your STAAD.pro creation of the model. Okay. Also, load combinations can actually be generated here. Soil bearing capacity factors based on your soil mechanics and your foundation design concepts can also be added. But then again, as I told you a while ago, these three uh, parameters are not so important in terms of the need to input them for you to be able to generate uh, a result that will take care of the footing design itself. And what is the most important is this last parameter, which is the job setup, wherein we will now create. No? So you just click create a new job to define the particular design footing or design and analysis job that we want to create. Okay, so as soon as you click this create a new job, you will see here on the right side a window pane or a data input pane that will let you uh, fill up some needed information like the job name. Let's say we want to call the job name design of footings. Okay, and then the job type, we can consider isolated footing, combined footing, mat footing, and design of pile cups or pile uh, footings. Okay, we have four choices here in this particular version. I don't know how about the other versions because I'm not using this uh, to tell you frankly in my actual design endeavors. Okay, so I will choose here an isolated footing, and then a design code must also be chosen. Of course, we will be using the American code as our basis because this is the nearest to the NSCP code. And the default unit type can also be changed from English to metric or the system, international system uh, we are using. And we can also select supports here by simply clicking some supports, or we can simply uh, 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 select the assign to all if you want all the footings, of course, to be designed. But sometimes it's not necessary to design them all, so we have a way of finding out which is the most critical. So we save time and space in doing the design. So, but for this particular lecture, I'd like to click assign to all supports, and there will be no supports listed here because automatically STAAD, or sorry, the STAAD Foundation will consider all the base reaction as your supports to be designed in this particular case. Okay. Now, for the available load case, you will see here that the load cases uh, placed here are also the load cases we have done in our STAAD.Pro modeling. But in case you added loads and load factors combinations here, automatically this will add up to the list of available load cases uh, you have here in this selection box. Okay. For purpose of discussion, I will only choose load case number 5 or load combination number 5. But in your actual activity, you have to choose which is the most, shall I say, practical, which is the most practical to be considered. Anyway, if you will choose everything, the STAAD Foundation will just try to design your footings based on all the available or the selected load cases and find out which is the most critical of them all. So, ganun lang ang gagawin. But to save again time and space and effort, I will only choose load combination number 5 for this particular case. So please look into the NSCP code as part of your activity, and these are the things I'd like you to discuss in your final report compilation. Okay, so considering this load combination now, we are through with our job creation, and then we just click create job, and the job uh, uh, is actually created. Sorry class, since I exited a while ago, kailangan ulitin natin yung create new job, no? Nawala yung tinype ko dito, no? Pinakita ko kasi kanina yun dun sa main navigator natin. So, I need to do or redo the inputting of this. Anyway, it's just easy to okay, I create a new job, and automatically you will see here a job or a particular step involving a design or isolated footing design job. So based on this job type, no, lalagay niyo ito. So if you have a lot of isolated footing job uh, that were created, it will be just be listed here, no, one at a time. If you want to create an isolated footing job just like this, lahat na sila. So it will just be placed here once. Okay, so next is to look into the design parameters. We have created the job, but we still don't have the design parameters. So one by one, we will fill up the design parameters on the basis of what our project specification has given us. Okay, let's say the concrete and rebar specification. We take note that the unit weight of concrete we use, I think, is 24 point something. So I don't know. You just check your notes. Okay, the minimum bar spacing and the maximum bar spacing here are 50 and 500. I think this is okay, no? But I want to change this maximum bar to 300. So it all depends on your choice, and also look at the code, of course, in filling up this. No, so strength of concrete is 20. I think we use 20.7 or 20 megapascal, and here we use 276. And the minimum bar size we use is, I think, 10, and the maximum bar size I think is 20. Okay, set as default. We don't want to set it as default, so we just use this as our parameter for this particular case. For the covering and the soil parameters, we have the soil type. If it is sand class, it's a drain condition. No? Pag yung soil mo is more or less sand, drain. Pag clay naman siya, you use the undrained condition. So assuming it's a sand, it's a drain condition. And then the bottom clear cover, I want to increase this to 3 inches or 75 millimeter. The unit weight of soil, we can use 22. The soil bearing, we can adjust it to 120. So you can have any value you want for as long as you have to justify, of course, why you have used that based on the codes and based on the assumptions you have made. Okay. So let's save this. Okay. So for the depth of soil above footing, so this just refers to the excavation depth, no? Depth of soil above, okay, above the footing. So I want to use 1,500 millimeter. For the surcharge loading, these are the fill, the embankment and other surcharge load you placed on your finish grade. Okay? Kung may nakapatong dun na surcharge like fill, embankments, etc. So let's not put a surcharge loading. Water table depth is deep, 10 meters. Kung gusto mong shallow siya, gawin mong 1 meter, maybe. Then cohesion, since this is drain condition, 0 siya. Hindi siya clay. Ano? Undrained shear strength, we don't need it. Minimum percent of contact area, 0 is okay. Then set as default, no. Okay, so we now move to footing geometry. These are just the minimum and the maximum you want to place in your footing geometry. So I want to place 300 here as my minimum thickness, and my maximum width and length, I want it to be 3,000. So the maximum thickness, I want it to be 1 meter maybe. And the plan dimension, I want to be frank, I really don't know what this plan dimension means. I have not used this, so you just check it out. Let's just leave those parameters we do not understand yet. Okay, the thickness increment, the offset, etc. Length to width ratio. If you want it's a rectangular footing, then you can make this as 2, 1.5, etc. If you want it to be a square footing, it's the length to width ratio is just 1. Okay. Okay, so we move over to sliding and overturning parameters. I think this is okay. Friction is 0.5 and the factor of safety is 1.5. So we now go to analysis and design. So what STAAD Foundation will do is to design it on the basis of Okay, so you'll see here now the design of the footing, okay, and also a tabulated footing design here. Okay, what the STAAD did is only design the footing 26. So I think on our job setup, we missed kasi inulit natin kanina, no? Inulit natin kanina yung creation ng job. Baka may na-click ako. So supposed to be all the footings must be designed. So let's double check the isolated parameters. Edit current job. Ayun, no? So hindi ko napansin ito, no? So I just select all support. Okay? So edit. You just edit it in case and then redesign it. So there you are. It's designing, it's actually doing a design of all the footings now. Ayan, kaya marami na siya, no? Okay. So these are the tabulations and these are the details. Okay, so when you do this, I don't want you to give me a lot of computations like this. What I need is a report, a summary of this, no? And of course the description and the interpretation based on some comparisons on the manual computation are the ones that are important. So thank you very much for listening. I hope you have learned uh, the basic procedure on how to design using this application. I'll see you on the next video.